Hello. In this occasion, we are going to solve problem 2.8.3b that asks us for which value of x is the matrix pictured here not invertible. And you see that in this lower corner you have a variable x, so that's the value that we need to figure out. Okay. So the idea of this problem is to use theorem 4 in section 2.8.3. So what the theorem says is that a matrix is invertible if and only if the determinant is non-zero. So the corresponding determinant for A. And because this is an if and only if, the opposite applies as well. So if A is not invertible, actually A is not invertible if and only if the determinant is equal to 0. So in this case, they're asking us for the value of x that will make the matrix non-invertible. So that means that I want to compute the determinant of A. And let me copy here A. So that's 70, 0, negative 7, 2, 9, 0, minus 30, 0, and x. So I compute this determinant, and I'm going to set it equal to 0. So when we compute this determinant, we want to be kind of smart about this computation, because as our textbook tells us, we can do the computation of a determinant along any row or any column. And if we choose this column that we have right here, then we are going to have a bunch of zeros and fewer computations. So let's see. Remember that when we're doing the minors, we have designs that correspond to each of these numbers. So if I have the Aij term, the sign that corresponds to this is going to be minus 1 to the ij, I plus j, sorry. So this is the term, the entry 1, 2, so this is going to be this power is going to be 3, so this is negative. Then this is going to be positive, and then this is going to be negative. Right? So just by checking at the indexes here and doing this computation. So the determinant of A is going to be 0 times the submatrix that I get by removing this row and this column. So that's going to give me removing that. Plus 9, and I remove this one and this one, so I get 70, negative 7, negative 30, x, and then minus 0. 0. And because I have those zeros, like I said, this term and this term are going to cancel. So at the end, the determinant that I have is going to be 9 times 70x minus and I want to set this equal to 0, remember, because of that. So I just simplify this. And I'm going to leave this already factor out. So 90 times 70x minus 210 equals 0. So you have a product of things, I forgot the x. When you have a product of things set equal to 0, that means that this part that I have right here has to be equal to 0. So this implies that 70x minus 210 equals 0, and then I just solve for x, and x gives me 3. If you look at the answers, that tells you that the answer is option A.